There are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning.
We already gave an introduction to supervised learning, and today we're diving into unsupervised learning, which is a type of machine learning where the model learns from data without any labels. In simple terms, the model is giving only the input data without any answers or outcomes. Its job is to find patterns or structures in the data on its own. Let's break it down. Unlabeled data means that the dataset has input features, but no correct answers or categories provided. The goal is to discover hidden patterns, relationships, or groupings within the data. But how it really works? Well, the model organizes or groups the data based on similarities it finds, all without being told what to look for. Here is a sample example. Imagine we have customer data such as age, gender, number of purchases, and the total value of purchases. We want to identify different types of customers, but we don't tell the model what those types are. This can be because we don't have time to manually specify the type of each customer, or simply we don't know ourselves. The model groups customers based on similar behaviors. For example, it might find that one group buys frequently but spends less, and another group buys rarely but spends a lot. These groups are formed based on patterns the model discovers, not the ones we specify. And that's why it's called unsupervised. Here are more examples. Video recommendation, like grouping similar users or videos to suggest what to watch next. Or anomaly detection, like spotting unusual behavior, for example, fraudulent transactions. Or even market basket analysis, like finding out that people who buy X often also buy Y. Or even image clustering, for example, grouping similar looking images together, like separating animal images from human images. There are many advantages of unsupervised learning. For example, there is no need for labeled data, which saves time and effort. It also uncovers hidden patterns that we might miss and helps understand the structure of the data, meaning that it can be useful before using supervised learning. The downsides are the following. First, it is less accurate than supervised learning in some cases. It is also hard to evaluate because we don't have labels to check that it's right or wrong. It can be computationally expensive as unsupervised learning models need a lot of processing power. It is also tricky to interpret and may not always be useful or clear.